Sanitary Fluid Products presents Understanding Heat Exchangers. What are heat exchangers? They are devices designed to transfer heat between two or more fluids of different temperatures. Depending on the type of the heat exchanger employed, the heat transferring process can be gas to gas, liquid to gas, or liquid to liquid, and it may occur through a solid separator which prevents mixing of the fluids or direct fluid contact. Heat exchangers vary according to the attributes of the processed fluids, such as viscosity, particle size, or temperature. They are used in the industry for controlling the temperature of food, beverage, and pharmaceutical processing of pasteurization, sterilization, and other hygienic operations. Heat exchangers make products safe for consumption and extend shelf life by preventing growth of harmful microbes. Milk processing. Heat exchangers pasteurize milk by raising milk temperatures. Ingredients in cosmetics and pharmaceuticals must be mixed at specific temperatures to ensure safe use and product quality. Because gasket, plate, and frame exchangers are among the most efficient designs, they are also among the most common designs in processing systems. Gaskets between plates guide the flow of product and heating cooling fluids through alternating channels. Here's how they work. As hot fluids pass over the plates, heat transfers from the hot to the cold side, decreasing the temperature of the hot side and raising the temperature of the cold side. Heat exchangers must maintain sufficient fluid velocity across the plates to transfer heat while also controlling pressure drops that can disrupt operation. Systems typically employ plate and frame heat exchangers for pasteurization, raw milk cooling, and cleaning in place heating. Given their sustainability for products with low to mid viscosity and few to no particulates, plate heat exchangers also are commonly used for beverage, beer, wort, eggs, sauces, and most dairy processing. In milk processing, chilled milk is heated from, for example, 4 Celsius to a pasteurization temperature of 72 Celsius and held at that temperature for 15 seconds and then chilled to 4 Celsius again. Heat always transfers from warmer substances to colder ones, so during pasteurization, heat exchangers use heat from the pasteurized milk to warm the cold milk, which saves heating and refrigeration energy. The process is called regenerative heat exchange or heat recovery, typically reaching 90% and achieving up to 95% heat recovery from pasteurized milk. Recovery is lower for higher fat products such as cream and ice cream mix. Regeneration has a positive impact on energy savings, capital costs, and efficient operation. Heat transfer occurs rapidly when the temperature differential is high. As temperature difference decreases, the rate of transfer slows down and stops altogether when temperatures equalize. Dairy Processing Handbook. Operators can have multiple sections on one frame to control the flow or hot or cold fluids when products have to be heated in one stage and then cooled in the next stage. For pasteurization, a multi-section heat exchanger uses connection places configured by different corner connections for single, double, pass-through, or blind channels. The design of the corrugated plates creates a large but compact total surface area for transferring heat. The heat transfer area of the plates features a herringbone pattern that creates high turbulence, which increases heat transfer and aids cleaning during CIP. The plate distribution area ensures an even flow of the fluid over the entire plate to maximize heat transfer. An optimized flow distribution also reduces uneven temperature zones that contribute to fouling. While the narrow flow path of the plate heat exchangers creates efficient heat exchange, the narrow path also limits its ability to process fluid to those with low to medium viscosity and few suspended particles that can result in fouling from particles getting caught on the plate contact points. For fluids that contain particles, two solutions are available. A low contact point, wide stream plate that can run product with more particle. Wide gap plates that can run more and larger particulate. Both allow particles to pass through while minimizing fouling. Shell and tube heat exchangers. Instead of transferring heat through parallel plates, shell and tube heat exchangers transfer heat between a bundle of tubes surrounded by a large shell vessel. Fluids that run through the tubes exchange heat with fluids that run over the tubes contained by the shell. Because of the diameter of tubes is physically greater than the gap between plates in plate heat exchangers, shell and tube exchangers are suited to applications in which product is more viscous, resistant to flow, or contains high density particles. Maximum particle size depends on tube diameter. Tubular heat exchangers can typically run longer between cleaning than plate heat exchangers in ultra high temperature applications. The basic shell and tube principle moves product through a bundle of parallel tubes with heating fluid between and around the tubes. A concentric tubular heat exchanger features tubes of different diameters positioned concentrically inside of each other, which is specifically efficient in heating for cooling because cooling fluids flow on both sides of the product tubes. Product tubes can be sized to meet the requirements for viscosity and particles. A concentric tube is specially suited to high viscosity, non-Newtonian fluids whose viscosity changes under pressure, shampoo, nail polish, or ketchup. As with other heat exchanger designs, shell and tube exchangers are set up to have product and heating cooling fluids flow in opposite directions. For example, cold product fluid travels from right to left in the heat exchanger, while the warming fluid travels from left to right over the product tubes. The counterflow configuration takes advantage of maximized temperature differences for more efficient heat transfer. One manufacturer, Pharmaline of shell and tube heat exchanger, operates at pressures of up to 10 bar and operating temperatures of 150 Celsius. Typical applications for the shell and tube heat exchangers include systems that process water for injection or purification, for example. In pharmaceutical applications, the risk of mixing between product and the heating or cooling medium is eliminated thanks to a double tube sheet design. Product flows in the tubes while the service fluid flows around the tubes inside the shell. Service fluids is sealed in the shell by one tube sheet, and second tube sheets seals the product. Heat exchangers with double tube sheets make leaks easy to spot because they appear at the joint in the outer tube plate. The heating fluid is sealed in the shell by the first tube sheet, and the second tube sheet seals the product. In the event of a leak, the leakage of either fluid is easily visually detected. Shell and tube heat exchangers are specifically effective in the pharmaceutical industry, where product hygiene and demand for isolating products from heating or cooling fluids are specifically high. To meet the industry's demands, high-quality tubular heat exchangers control microbe growth and prevent cross-contamination. Some of the newest tube-in-tube designs for pharmaceutical applications feature high shear force and turbulence to maintain efficient transfer of heat while reducing biofilm. Smaller, lighter weight heat exchangers designed for tighter spaces can be effective substitutes for larger tube heat exchangers. They feature the same hot and cold fluid flows through alternating channels that create hard turbulence for high heat transfer efficiency, while using 50 to 80% less heat transfer area. The many processes involved in manufacturing food, chemicals, pharmaceuticals, cosmetics, health, and beauty products all require reliable heat transfer that prevents falling from viscous and sticky products. In other processes, scraped surface heat exchangers are the right choice. Their ability to process fluids with a high number of particulates of high viscosity make them more efficient in those applications. Scraped surface heat exchangers are more expensive than other exchangers, but they work efficiently when other heat exchangers would be ineffective. In scraped surface heat exchanger applications, the product enters the cylinder at the bottom and flows upward. The heating or cooling medium travels through a narrow right-shaped annular channel. Typical processing applications include ketchup, mayonnaise, spreads and fillings, sauces and puddings, baby food, skin lotions, or shampoos. Scraped surface exchangers are fitted with rotating blades that remove product from the cylinder wall to maintain consistent heat transfer. They're designed specifically for gentle product handling to avoid interference with product quality and consistency. Scraped surface exchangers are typically mounted vertically inside an electric motor, turns on rotor fitted with scraping blades. To prevent damage to product, rotors and product move through the heat exchanger in the same direction, with product entering at the bottom and exiting at the top. Scraped surface heat exchangers are common in the food and personal care industries. Ensuring continuous production requires uniform heat transfer, but the consistency or content of some food product hinders efficient heat transfer. Scraped surface heat exchangers meet the need for efficiency by keeping product off the walls and the mix where it belongs. In dairy processing, products have high protein content that can foul exchangers. Fouling occurs when processed fluids sticks to internal surfaces and build up over time, reducing efficiency. So part of a good hygiene program includes using equipment that stays clean for a long time and is easy to clean during cleaning plays. Fouling can increase pressure to heat exchangers subject to fouling or scaling should be cleaned periodically. A light sludge or scale coating on the tube reduces its thermal efficiency. Since the difficulty of cleaning increases as scale thickness or deposits increase, operators should perform routine checks to catch fouling sources early. We would love to help you with any of your production needs. Contact us on info@sanitaryfluidproducts.com or call us at 855-910-4562 for a free quote. sanitaryfluids.com